driving larger capacitive load. So when we driving larger capacitive load, we understood that the channel length, that is length and width, will plays an important role along with the capacitance what we are going to use for the storage of the capacitor. So with that, there is one more type of buffer. We are going to call it as a super buffer. So the normal buffer and super buffer, what are difference is that the capacity of passing the charge electronics over the super buffer, it will be large when you compare to the normal buffer. So we can see here this super buffer, it is resembling the circuit diagram of inverter only, but only some changes has been done. So what changes it has been done is that you can see here, there we have one inverter and one inverter is been connected to another inverter, but the how you are connecting the one inverter to the next inverter, there is the difference is there. So you can see the gate of the NMOS depletion transistor, it has been connected to the gate of the that is PMOS depletion transistor, it has connected to the NMOS depletion transistor. Similarly over here you can see at the bottom line, the PMOS transistor is being connected to the NMOS transistor. So means what? The gate and gate are connected and the top gate has been short circuited with the drain and drain terminal of the PMOS transistor and the NMOS transistors. So with the use of super buffer, we can have a stability over the network. Along with the stability, it can able to pass the transmission with a lesser propagation delay. Okay, so therefore we are going to use this CMOS, that is a buffers, as a super buffer. Okay, so the next thing is we are going to go for a BiCMOS drivers. Okay, so we know that BiCMOS drivers, how we are going to fabricate the BiCMOS drivers. So basically BiCMOS drivers are nothing but it is a integration of both bipolar junction transistor. Along with that, it is a CMOS technology. Means BiCMOS has been fabricated with a two combined methodology. Means it will hold the bipolar junction transistors also, and also it will hold the CMOS technology also. So therefore when you design or when you want to drive the any transistor elements or the electrical circuits in the VLSi design by the use of this BiCMOS technology, then you need to take the considerations and the operating principles of both the bipolar junction transistors and also the VLSi technology you need to understand. Okay, so the basically this BiCMOS drivers, why we go for that? We will go for these BiCMOS drivers mainly because of the following benefits. So what are the following benefits it provides is, the first one is high speed of operation. Through the use of these BiCMOS transistors, we can increase the rate of propagation or the rate of transmission of the devices with a faster method. So therefore we can say that the BiCMOS drivers will operate at a highest speed. The next one is high packaging density. So if you design an IC only with the use of your bipolar junction transistor, means then the circuit will be bulky, and along with that bulkiness, the propagation delay will be more, and also the size of the devices in the case of bipolar junction transistor only if you use MATE, then the packaging density will be less in the case of bipolar junction transistors. So in order to avoid this bipolar junction transistor, so wherever possible is there, so that we can accommodate this CMOS technology on the existing bipolar junction transistor, so we can increase the packaging density. So therefore, with a combination of bipolar junction transistor along with this CMOS technology, we have created a BiCMOS drivers. So with the use of this BiCMOS drivers, we can increase the capacity, that is a packaging capacity of the circuits. And the last one is these BiCMOS drivers will provide a low power dissipation for the data transmission. So why they will provide a low power dissipation for the data transmission is because since the CMOS technology will work for the low power data transmission, and the bipolar junction transistor will go for the high polar junction transistors. So if we combine this CMOS technology along with the bipolar junction transistor, the average power dissipations over the circuit when you compare to only for the bipolar junction transistors, it will be minimum. Okay, and one of the simple inverter circuit which has been given in the diagram. So you can see here we have one resistors along with the resistors, and we have one capacitor. So here what we are trying to understand is the amount of charge which can be hold in a driving capacitor, that is CL. We want to try to measure, and because of this, so we have included one input resistors. Along with that input resistors, we have connected one resistors. So the time taken or the amount of charge it was going to discharge from this bipolar junction transistors, we want to understand. So for that we have given the time delay. So what is the time delay is, so we want to calculate, so how much is the time that is a charging capacitor wants to take in order to charge to the fullest extent, will be given by the expression that is nothing but delta T is equal to CL divided by GM, where GM is nothing but the transconductance of the device what we are going to use. So with the use of this time, so we can able to say that these bipolar junction transistors will provide a faster propagation rate of data information over this BiCMOS drivers. Okay, so and along with this BiCMOS drivers, so you can see here the amount of delay which has been incurred by the inverters will be calculated by the expression that is nothing but T is equal to Tn plus V divided by ID into 1 divided by HFE into CL. Okay, so where Tn is nothing but the time to charge of the base or the emitter junction, and HFE is nothing but the transistor current gain. Okay, so and this transistor current gain we are going to measure in the common emitter mode. So since the bipolar junction transistor will work on three different mode, that is nothing but common base, common emitter, and a common collector. So in order to drive the capacitor with a fullest current, we go for a common emitter configuration. So you can see here with the use of CMOS just technology, the slope of Vin, so it has been growing drastically. That is nothing but you can see here V divided by Vd. So this is the first slope you can see with the use of only BiCMOS means CMOS technology. But whereas with the case of this BiCMOS technology, so you can see the slope has been increasing, even though it is increasing, but it is gradually increasing. So with the use of this delay in the circuit, so what we can come to a conclusion that, so this BiCMOS technology, even though it provides or even though it exhibits a delay in the data transmission, but when you compare to CMOS technology, the rate of increasing in delay over the entire circuit, it is less when you compare to your CMOS technology. Okay, so this is one of the means so the functions. What is the difference between your CMOS technology and BiCMOS technology? We can see it over here. And why it has been reduced is because of the one of the important parameter what we have considered in the BiCMOS technology is the BiCMOS inverters. So basically this BiCMOS inverter, they will reduce the delay depending upon the transconductance, that is the conductance of the current gain of the CMOS inverter technology. So because of this CMOS inverters means the transconductance inclusion in the BiCMOS technology, the slope has been reduced. For the good data transmission and for the good propagation of the signal from transmitter to source, so we should have a minimum delay. So this minimum delay can be exhibited in the BiCMOS technology, and it is more stability when you compare to a CMOS technology. Therefore we go for a BiCMOS technology. Okay, so did you understood this one?
Yes, sir.
Okay. Okay. So now we will go for the next one. Okay. So the next one is the last one you can see here, the BiCMOS inverters as a function of resistance. So now you can see here the gate delay we are plotting against the collector current. So you can see as the collector current increases, the gate delay will also increases. Why? Because the channel length will reduces or the channel resistance will increases. So when the channel length increases means then the electron flow of electrons from source to drain will be hindered, that is the mobility will be reduced. So because of reduction in the mobility, so there will be increase in delay will happen. So you can see, and also this transconductance, so we can increase or we can reduce depending upon the capacitive load. So you can see when the capacitive load it is 0.1 PF, so there was a delay was less in the case of the BiCMOS technology. When you increase that, that is the driving capacity of the capacitor. So when CL was 1 picofarad, then the delay was taken, or it has been increased exponentially in the linear curve. So therefore, when you use this BiCMOS inverters, so you should make sure that these BiCMOS inverters, especially it will be, we are going to use for the low power transmission range, and for the lower capacity loads, these BiCMOS inverters will work. And even though these BiCMOS inverters will work for the higher capacity load, but with an increased delay, so we can able to work these BiCMOS inverters. Okay, so this is one of the simple diagram which depicts how your BiCMOS inverter delay is in against with the collector current. So in general, if the collector current increases, the delay will be increases. This is by default that the channel length will reduces. So because of this channel length, so when the electrons wants to flow from source to drain in the provision of the gate voltage, there will be mobility will be hindered because of the collision. So because of the collision, the resistance will increases. So therefore, the delay in the BiCMOS inverters will increases. So as the capacitor, that is a collector current resistance, will increases. Okay, so this is the completion of this module number 2. So I know that this module number 2 I have taken a lot of classes. So why? Because I wanted you people to very thorough with the stick diagram, because the stick diagram, those are the important concepts in the module number 2, and also the lambda based design rules. So among these two, definitely one question will be appearing for your main examination, and I request all the students kindly go through this concepts very well. And also in the gate examinations, so the stick diagram related questions they will be asking you, and lambda based design rules they will be asking you. So I request all the students kindly go through it and try to study well this stick diagram and lambda based design rules, especially when you go for placement, and also placement for also in the case of VLSI technology. So they will be asking you basic questions related to VLSI technology. So they will be asking you how you differentiate the NMOS transistor and PMOS transistors, and what is the difference between depletion mode transistor and enhancement mode transistors. How, what is the symbol is there for NMOS transistor and the PMOS transistors. So what are the different steps are there? What are the different steps are there in the fabrication of CMOS technology? What is the difference between the NMOS fabrication process and PWEL fabrication process, and also the tin work fabrication process? So they will be asking you these questions. So I request all the students kindly go through these concepts once again and thorough with this module. Okay, so this completes your module number 2, and if you have any doubts means, so you can ask me the doubts. So we will have a clarification on those, and then we will have a small quiz related to this module number 2, and then we go for the module number 3. Okay, so I will give you 2 minutes of time. So kindly go through the previous pages what you have written, and if you have any difficulty, or if you find anything has to be explained once again means, so that I will explain you once